Good morning, children. Children, we have completed the theory portion of the unit solutions. Now, let us take up some of the numericals under this unit solutions. Before taking up some of the numericals, let us list down whatever the important formulae you have learned under this unit. Children, the first one was mass by mass percentage. But mass of solute upon mass of solution into 100. Second one, mass by volume percentage. Is it not? What is that? Mass of solute upon volume of a solution into 100. Third one, volume by volume percentage is equal to volume of a solute upon volume of solution into 100. And the next one, parts per million. What is that? ppm. Nothing but mass of a solute upon mass of solution into 10 to the power of 6. After that, children, you have learnt about molarity. Fifth one is molarity denoted by capital M. Nothing but number of moles of solute upon volume of a solution in liter. Or you can also write, look at here, WB, right, M is equal to WB upon MB into 1000 upon volume of solution in ml. This is very important for solving some of the numerical. We will take it later. Next one is molality. It is denoted by small m. Children, number of moles of a solute upon mass of solvent in kg, or M is equal to WB upon MB into 1000 upon WA. After that, we have learnt about mole fraction. Mole fraction. What is mole fraction? Children, the mole fraction of the component is equal to the ratio of moles of each component to the total number of moles of all the component present in that solution. Is it not? Look at here. How do I write that? Please look at here. Mole fraction, it is denoted by chi. Imagine I am going to write chi A. Now that is Na upon Na plus Nb, or chi B is equal to Nb upon Na plus Nb. And you know this, for a binary solution containing two components, the sum of the mole fraction of both the components is equal to 1. Is it not? Children, after this, you have learnt about Henry's law. What is that? Henry's law. And the Henry's law, you learned that P is equal to KH into Chi. Is it not? Now next one is Raoult's law. The ninth important formulae which you learnt under this chapter is for Raoult's law. Children, you can write Raoult's law for a solution containing two volatile solvents as well as a solution containing a non-volatile solute in volatile solvent. Look at here, A solution of two volatile solvents. How do you write that? You know that PA is directly proportional to CA and PB is directly proportional to CB. Is it not? Now PA is equal to PA naught into CA and PB is equal to PB naught into CB. Moreover, according to Dalton's law of partial vapor pressure, P total is equal to PA plus PB or PA naught into GA plus PB naught into GB. And similarly, I am having for solution containing a non-volatile solute in a volatile solvent. Look at here. PS is equal to PA naught into GB. PA naught into GB. Is it not? Whereas GB is equal to, you know that, PA naught minus PS upon PA naught. PA naught minus PS upon PA naught. This is nothing but relative lowering of vapor pressure. Now what do I do? In general, please look at here. In general, Chi solute is equal to P naught solvent minus P solution upon P naught solvent. This is in general for Raoult's law for a solution containing a non-volatile solute in volatile solvent. Is it not? After this, you have learnt about colligative properties. 10th one, colligative properties. What is the colligative property? Any properties which depend on number of a solid particle but independent of nature of solid particles. Is it not? Now under this, you have learnt 4 different colligative properties. Number 1, you have learnt about RLVP. What is that? Relative lowering of vapor pressure. How do you write that? Please look at here. PA naught minus PS upon PA naught. Is it not? Is equal to WB into MA upon MB into WA, where look at here, WB is nothing but weight or the mass of a solute and its molar mass is MB, whereas WA is weight or mass of a solvent and its molar mass is MA. Hope you understand that, right? Now second one, elevation in boiling point. Is it not? Now delta TB is equal to KB into M or KB into WB into MA upon MB into WA. So this is also correct. Why? You are substituting the value of M in this formula. Hope you are getting that. Next one, we have depression in freezing point, that is delta TF. Delta TF is equal to KF, that is Kraskopik constant, into molality. And I can rewrite this delta TF is equal to KF into WB into MA upon MB into WA. By using this, you can find out molar mass of any non-volatile solute. The next one we have, what is that? Osmotic pressure. Osmotic pressure denoted by pi. Is it not? Osmotic pressure, pi is equal to CRT. Is it not? This can also be written as, please look at here, pi is equal to WB into RT upon MB into V. Okay. So these are the 4 important colligative properties here learned under the heading RLVP, relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. Let me go for the next one, that is Van 't Hoff factor. Denoted by I. Children, I said if any non-volatile solute undergoes either association or dissociation in the solution, then we need to change or modify the formula of colligative properties by inserting Van 't Hoff factor, that is I. Let me take up the first one. What is that? Relative lowering of vapor pressure. Is it not? How do I write that? PA naught minus PS upon PA naught is equal to I into GB. I into GB, or I into, look at here, WB into MA upon MB into WA. This is also correct. So this you need to remember. Second one, elevation in boiling point. Elevation in boiling point. How do I write that? Please look at here. Delta TB is equal to I into KB into M. Here also inserted I. Is it not? Next one, depression in freezing point. How do I write that? Delta TF is equal to I into KF into M. Okay. So molality formula, you can put there. The last one we have, what is that? Osmotic pressure. Osmotic pressure. How do I write that? Look at here. Pi is equal to I into CRT. I into CRT. Okay. So these are the modified formulas for colligative properties in case non-volatile solute undergo either association or dissociation by inserting Van 't Hoff factor. 11th one is degree of association. Degree of association and dissociation. Look at here. Let me write first degree of association. Alpha is equal to I minus 1 upon 1 by M minus 1. M or N doesn't matter here. And alpha dissociation is equal to I minus 1 upon M minus 1. So these are the different formulas that you all learned under the unit solutions. With this introduction, let me take up some of the numericals for you. Children, let me take up the first numerical of this unit solutions. 2.82 grams of glucose with molar mass is equal to 180 unified mass is dissolved in 30 grams of water. Calculate A, molality, and B, mole fraction of glucose and water. Very simple, children. You read the numerical for 2 times and then you list down whatever that data is given here. Okay. A. Calculation of molality. It is given by M. Now, what is given? Look at here, WB is the weight of the solute. The solute is the glucose here, 2.82 grams. Is it not? And the molar mass of glucose is also given here. MB is equal to 180 unified mass. What is they given here? Weight of water, the solvent, that is equal to 30 grams. What are they asking? They are asking molality. And you know the expression molality is equal to WB into 1000 upon MB into WA. Remember, we had taken a capital B for always solute and capital A for solvent. WB is how much here? 2.82 into 1000 upon MB is how much here? MB is equal to 180 into WA is 30. Children, if you simplify this, you are going to get 0.522 approximately. This is your M. The second part of this numerical is finding the mole fraction of glucose and water. That here, calculation of mole fraction of glucose and water. Look at here, Gb, this is for what? Glucose, is it not? NB upon Na plus Nb. What is Nb here? Number of moles of glucose. Na is number of moles of water. Let me calculate Nb. Nb is equal to Wb upon Mb. What is this? Number of moles is equal to given mass upon molar mass. What is the given mass here? Given mass is equal to 2.82 grams upon 180 unified mass. Is it not? In that case, you are going to get, look at here, 0.0157. 0.0157. Similarly, I can calculate Na. Na is equal to Wa upon Ma. Now, Wa is how much here? Wa is 30. Much here? 30. And how do you find out this molar mass of water? You can calculate molar mass of water by adding atomic mass of all the atoms of the element present in that molecule. Look at here. So there are 2 atoms of hydrogen in water, that is 1 into 2 plus 1 atom of oxygen, that is equal to 18 unified mass. It's 18. Hope you're getting that. Is it not? In that case, you are going to get 1.67 value. Now, once you get NB and Na values, then substitute the value here. Look at here, NB is equal to how much? 0.0157 upon how much here? 1.67 plus 0.0157. Children, if you simplify this, you are going to get 0.009. 0.009. This is what G of solute glucose, otherwise mole fraction of glucose. Hope you are getting that, mole fraction of glucose. Children, once you find out Gb, it is easy for you to find out Ga also. Tell me why? Because it's a binary solution, and you know that for a binary solution, sum of the mole fraction of both the components present in the solution is equal to 1. So in that case, please look at here, Ga plus Gb is equal to 1. Is it not? Now, Ga is equal to 1 minus Gb, 1 minus 0.009. Hope you're getting that. Then you're going to get 0.991. This you are going to get the answer for the mole fraction of water. Very simple numerical. You need to understand and you have to put the formula and substitute the value. You are going to get the answer. Okay. So let me go for the second numerical now. Children, let me go for the second numerical. A solution of glucose in water is labeled as a 10% weight by weight. The density of the solution is 1.29 gram per ml. Calculate molality, molarity and mole fraction. Children, 10% solution of glucose means 10 grams of glucose present in 100 grams of solution or 90 grams of water. Hope you understand that. Now let me take up the first part of this numerical, that is molality. Small m. Now let us list out. WB is how much? 10% refers to 10 grams. WA is how much? That is equal to 90 grams of water. Because 10% weight by weight. So MB of glucose that you need to calculate, that is 180 unified mass, and you are supposed to find out molality. And you know the expression for molality, WB into 1000 upon MB into WA. Now WB is how much here? WB is equal to 10 grams into 1000, MB is equal to 180 into 90. Children, if you simplify, then you are going to get 0.617 molality. One part is over. Let me go for the second part. That is molarity, capital M. So molarity expression, you know what? M is equal to, what is that? WB into 1000 upon MB into volume of solution in ml. Now we need to find out the volume here, is it not? Now volume of solution is equal to mass by density. Why? Because density is equal to mass by volume. Now mass is how much here? Mass is equal to how much? Right, tell me how much? This 100 upon density is how much? 1.29. So if you calculate, you are going to get 83.83 ml. That means we got a volume of the solution. Now I'm going to substitute. WB, you know just how much? 10,000 upon MB is how much? 180 into volume of the solution is 83.3. Children, if you go for calculation, you are going to get 0.667 molarity. This you need to remember. Next part is, what is that? Mole fraction. What is that? Mole fraction. And here is the formula for mole fraction. Gb is equal to, what is that? NB upon Na plus Nb. Na plus Nb. For this, children, first you need to calculate number of moles of glucose as well as number of moles of water. Look at here. Nb is equal to Wb upon MB, and similarly Na is equal to Wa upon MB. Now WB is how much here? That is 10. MB, you know that? 180. What is that? 180 grams. That means you are going to get 0.0555. 0.0555. Right? Now similarly, water, W is equal to 90, and molar mass of water, you know that you can easily calculate 2 atoms of hydrogen, 1 atom of oxygen, 2 plus 16, that is 18. What is that? That is 18, and we simplify that. 18 5s are 90. Now I substitute the values here. Look at here. NB is how much? 0.0555 upon 5 plus 0.0555. Children, if you simplify, you are going to get 0.010. This is what? Gb. So once you know the Gb, that means for the glucose, you can also calculate mole fraction of water. How do you know that? For binary solution, for binary solution, sum of the mole fraction of the components is equal to 1. Now Gb, Ga is equal to 1 minus Gb, 1 minus 0.010. Children, if you calculate that, you are going to get how much? 0.9. How much? It is 0.9. Let me take up the third numerical. A sugar solution of weight 214.2 grams contain 34.2 grams of sugar. Sugar formula is C12H22O11, that is nothing but sucrose. Calculate A, molal concentration. Molal concentration is nothing but molality. B, mole fraction of both the components. Children, understand the question. For that you need to read the question 2 times. Let me take up the numerical. Yeah, please look at yeah. What are they given? Yeah, weight of sugar solution. How much? 214.2 grams. Is it not? Then what is they given here? Weight of sugar. How much here? It is 34.2 grams. You know that weight of water in a sugar solution, in sugar syrup or solution, is equal to, look at here, 214.2 minus 34.2. You are going to get, what you are going to get? The weight of water in sugar syrup or sugar solution. It is equal to 180 grams. What that? 180 grams. Now we need to find out molar mass of sugar. Formula you know that, says 12H22O11. If you put the atomic mass, you are going to get 342 unified mass. You can do that. Hope you understand that. Now let me take up the first part of this. What is that? Molality. Molal concentration is nothing but molality. Molality. Children, molality M is equal to WB into 1000 upon MB into WA. WB is how much here? 34.2 into 1000. MB is how much here? 342. WA is how much here? How much? 180. Children, if we simplify this, you are going to get 0.55 molal concentration of solution. Once you know this, you can go for the second part, that is B, mole fraction. Mole fraction. Now Gb is equal to NB upon Na plus Nb. Hope you can do that. If you find out Gb, we'll get some value and then you apply for binary solution. Ga plus Gb is equal to 1 and Ga is equal to 1 minus Gb. Hope you can solve this. Not an issue, no? You can solve this.